Hello, my name is Marissa Hunter, and today I'm going to be sharing my CUDA code versus my C++ code and showing how CUDA can speed up the runtime if used correctly. The way CUDA is most effectively sped up is when you run threads in parallel. The code I've written does not optimize this, but it does show that adding more threads will result in a faster runtime, adding more blocks, adding more threads, because the GPU runs those in parallel. So as they're running at the same time, they will speed up the runtime. All right, so let's start with my code in C++. I have created 3 vectors. I have populated vector A and B with 10 numbers. N is the 10. And then I have added them into C. I have used the CUDA event and CUDA record time to record how much time elapses during the runtime. And then I have printed out my results in the last commands. Let's see if we run the code here. It results in what we expect: 0 plus 0 is 0, 1 plus 10 is 11, and so forth. And it says that the runtime is 0.003456 seconds. So that is very fast. On its own, the CPU is faster than the GPU, but the optimization comes when you run the GPU in parallel with multiple threads, parallel threads running at the same time. Again, my code does not optimize this. As you can see here, I have 1 block per grid and 1 thread per block, which is the least optimal way I could be doing this, but we will change that to show how much it speeds up when I do. Okay, so here's my code. It is pretty much the same idea, but instead of running the body of the code in main, I'm running it in a function called add, where I add A and B and put them into C, and then I call that function in, oh yeah, this line down here. Whoops. I run it in, I call the function down here. Okay, and then I have to allocate the memory, get the memory onto the CPU and then back onto the GPU. So there are more steps that go into this CUDA code. But at the end, we print it off and record the time elapsed, just like the last one. All right, let's run this one. All right, so it does the exact same thing. Of course, these are floats instead of ints. And the required time is 0.968, which is slower than the CPU, which is what was predicted because the GPU is slower than the CPU unless optimized. All right, let us change threads per block. So now we will have a 2x2. So we'll have these 4 blocks running in parallel, and that should speed up the runtime. Let's try this again. It was 0.9 before. Oh, did not speed up the runtime. It's 1.00. Well, let's try it again. We'll try 3x2. There are definitely other ways to, yeah. All right, so this isn't speeding up the runtime right now, and the reason for that is that my code is not written in a way to optimize parallel threads. But if this were written in a way that certain threads were in charge of computing certain numbers, while other threads were in charge of computing maybe the second half of the i's, then the CPU would be faster. But because we do not have these threads optimized running in parallel, the GPU is slower. But if optimized, the GPU using CUDA or CUDA using the GPU would result in a faster runtime. Yes, in conclusion, my add function did not speed it up, but with optimized code, it could, using the threads in parallel. Thank you for listening to the presentation.